Turn the wrinkle. So, where are we? How many people got through A? Yeah. Did anyone also get through B? C? Anyone made it to C? So there are probably some inefficiencies here. We'll clear that up. I'll also talk about how to be more efficient. In terms of what you should actually be doing, I already told you everything, but sometimes the order in which you do it might actually make things easier versus harder. Let's start with the first one. Now with 2x2s, it's not so bad, but once you get to 3x3s or higher, then you have to start being very careful how you're doing things, because sometimes you might even be undoing something that you already did, you're not sure. Okay, let's actually look at it. So it says we want to solve this using Gauss-Jordan elimination, which means we want to translate it to a matrix and do row operations to get it in reduced row echelon form. Not completely necessary. I'll probably make a slight detour to show you how you can stop short of this form and still get the answer, but let's actually just do that. So, augmenting the system. So step one. Augment the system. So, what would that look like for this guy? First row.
1, -1, -1.
Second row.
2, +1, 4.
Right. You put a bar here just to make a mental note, though it's not completely necessary. Yeah, so that's where we're starting. Now, how are we going to get this into a nice form? What was the first thing you did? Ideas?
Took 2 times the first row minus the second row.
Okay. Now I would put that in the second row. So 2 times row 1, and you subtract row 2. So 2 times this minus that, 0. 2 times this minus that, minus 3. 2 times this minus that, minus 6.
How do you determine which row you put that in?
Because you're after a certain form. Now, and I would leave row 1 here. Now, yeah, why did I put the result in the second row as opposed to the first row? Remember, there's a goal I'm heading for. I want the first non-zero number in the row to be a 1, and I want all subsequent 1s to be to the right of the one that's above it. So, if I had put this the other way, like 0, minus 3, minus 6, 1, minus 1, minus 1, what would have happened is the first non-zero number in the first row is going to be over here, while the guy in the next row is going to be to the left. Right? So again, I really understand what form I'm heading for, and all my moves is trying to tailor it to that form. So I definitely want to put the situation where there's a 0 here in the bottom row to create this kind of cascading off to the right. That's the goal. So that would be my first step. Now, we can clean this up a bit by taking row 2 and dividing by minus 3, and you get what? 1 and 2 here. Okay. Now, here's a slight detour that we can make. It's not Gauss-Jordan elimination if we stop here, but side note. We can stop here if the point is to solve the system. It's a REF, which is good enough. Now at this point, what you would actually do if you wanted to stop here is you start from bottom row up. Translate to equations. And back substitute. Now what that would look like in this case, for example, is, notice in row 2, if I were to translate what row 2 says into an equation, what would that equation say? it would say y equals 2. Now what I'm going to do is I'm going to move up to row 1. If I translate that to an equation, it's going to say x minus y equals minus 1. And now I can back substitute, meaning I can substitute the expression for y into here. And so I would have x minus 2 equals minus 1. And so then I would get x equals 1. And I could solve the system from this stage. Now, let's actually go further because the instruction said Gauss-Jordan elimination, which means we want to actually go all the way to reduced or echelon form. And what makes this not in reduced or echelon form? Yeah.
There's a number above the 1 in the second row.
Right. This guy should be a 0. So that's what I don't want. So now I know the next step I'm going to take, the purpose of that step is to get a 0 in that position. Anything else I do that doesn't get a 0 in that position is considered inefficient. Right? And it's also important that I want to maintain this 0 that I already fought to get. Right? So I want to maintain the zeros in the right positions while simultaneously getting zeros in convenient positions. Okay. And the operation that I choose is always to get this goal. Okay. So to continue this, how would I get a 0 here? Yeah?
Row 1 plus 1, row 2.
Right. Now if I add these two, the minus 1 plus the 1 is going to give me that 0. So that's what I'm going to do. Row 1 plus row 2. 1 plus 0, 1. This plus that, 0. This plus that, 1. And then I just recopy the second row because that's already in a nice form. So this is the reduced row echelon form. Now here, this means x equals 1 and y equals 2 immediately, right? I didn't have to do any extra work, right, to figure out what x equals 1, that x equals 1 and y equals 2. I could literally just read off the answer in this position. So that's somewhat what your first step should look like. And probably did an extra step here just to clean things up a bit. So you should have been able to get through the first problem in like with 1, 2, 3 extra steps and not much more. Any questions on what happened here? Okay. So now, so that was step 1, and step 2 was to actually reduce row reduction. But that in and of itself, there's an art to it, there's a strategy to it. You don't really want to be doing things that you don't have to be doing, and undoing things that you already did. And this becomes more important the larger the system is. So let's look at the first 3x3 system. And I'll talk a little bit more about the strategy of how you want to get through this. I was reading from the wrong line. Minus 2x plus y minus z plus 4. X plus 2y minus 3z plus 8. You would have already copied this down. You don't have to copy it down again. Minus 2x plus y minus z equals 4. X plus 2y plus 3z equals 13. 3x plus z equals minus 1. Okay. So let's look at this one. So again, I have the definition of what it means to be in reduced or echelon form in my head. Every move I make is for the purpose of obtaining that form. That's the first thing. I know on my way to obtaining this form, there are only 3 legal things that I can do. I will do nothing other than these 3 legal things. So that's the name of the game. First you augment. 1, 2, 3, 13, 3, 0, 1, minus 1. Now, I know that I kind of want these leading ones kind of cascading off to the right, and so probably having a leading 1 in the top left is going to be a good thing. So in terms of strategy here, establish top most pivot first. That's going to be as far up and as far to the left as you can possibly see a non-zero number. You are going to want to make that position into a pivot. By the easiest means. Okay, so now there are only 3 means. You're going to pick the easiest one to apply in the first situation. Okay, so with that in mind, I know I want the top left corner to be a 1. What is the easiest way to get the top left corner to be a 1? Yeah.
Add row 3.
Add row 3 to what?
Row 1.
That is a way to get a 1 there, but was it the easiest way? Swap these two is even easier, right? That's even less arithmetic, right? So I would use the move of swapping the 2 rows. So I would actually swap row 2 and move it to row 1. That's the first position. Now, here's the next, I'm not filling out the matrix yet because here's the next piece of advice. Once pivot is established, immediately, as soon as possible, get the zeros below it. Okay? So my very next step is to have a 0 here and here. Now the longer you get to make that the reality, the more inefficient you're being. So now I'm going to think, among the 3 things that I know are legal, what are the things that I can do to get a 0 in this position and in this position? Okay, so based on what I have, what do you think? How can I get a 0 in the second row? Yeah?
You can multiply the first row by -2 and then add that to the second row.
Or you mean multiply this by
Yeah.
2 and add it to that,
yeah.
right? Now my labels are going to refer to the previous matrix. So that's one way to get a 0. If I multiply this by 2 and add it to that, it will create a 0 in this position. So that's what I'm going to do. Take 2 times row 2 and add it to row 1. This is a legal move. This is a type 3 operation. So what I'm going to do is exactly that. 2 times this plus that gives me the 0. Okay? 2 times this plus that gives me a 5. 2 times this plus that gives me a 5. 2 times this is 26 plus that gives me a 30. So that is my second row now. Now, using 2 rows other than row 1 and row 2, how can I get a 0 here?
Do row 3 minus 3 times row 2.
Yeah, so you can even write that down. So you know what you're doing, row 3 minus 3 times row 2. So I'm going to take 3 minus 3 times this. That will get a 0. 0 minus 3 times that gives me a -6. 1 minus 3 times that gives me a -8. Minus 1 minus 3 times this gives me a -40. So your second step should usually look something like that. You notice here I've established the top leftmost pivot and I've gotten the zeros below him right away. Now sometimes you want to actually make your life a little easier, so you might throw in an extra step just to kind of make things a little nicer, in the sense that of reducing the numbers, say. The smaller the numbers you're working with, the better it is for you. So I'd probably just take an extra step and just make things a little bit nicer here. So again, I'm going to leave that because that already has what I want in this position. But this, notice that I can reduce all these numbers. Right? So I can take row 2 divided by 5. And here I can reduce by what? Maybe like a 2. Take row 3 divided by, say, a negative 2. That would be 0, 3, 4, 20. Okay. So, strictly speaking, this is a extra step to reduce. Like a computer wouldn't do this, but as a human being, you might need to give yourself a little extra help. Working with smaller numbers is easier. So now, you are basing your entire game plan on the pivots. So I've created the one that's in the uppermost, the highest possible one. And so now, what you're essentially going to do for the rest of the game is to repeat for successively lower pivots. What I mean, I've created a pivot in the first row. My next goal is to create a pivot in the second row. And then my goal is going to be create a pivot in the third row. Then create a pivot in the fourth row if there was one. I'm going to keep going down by rows and creating my pivots. Now, where would the pivot in the second row show up? Well, in this position. He's actually already there. He's already a 1. Now, once I create a pivot, and this one is already there, what is the goal? Immediately get zeros below it. So now my next goal in mind is to kill this 3. Right? There's like a method to the madness. I'm not just randomly doing these 3 operations hoping for the best. There's a specific goal for every step. Right? I want to get these pivots cascading off. So I establish the pivot, get zeros below it. Establish the next one, get zeros below it. Establish the next one, get zeros below it. And just I keep going that. It keeps a certain order to things. Yeah.
Oh, you get zeros in top too. You said it was like
Yeah.
trying to get RREF?
Yes. But those come after.
Oh, those, okay.
Right. So I'm kind of going through how you would kind of think of the strategy. The first thing I would do is get all the pivots, get zeros below them. After that, I'm worrying about getting zeros above. Okay. So, yeah. So now I know my goal is to kill that 3. How can I actually kill that 3? Legally. So for now, my first 2 rows are fine as far as I'm concerned. I need to change the third row to get a 0 here. What can I do? Yeah?
Subtract the third row by the second row multiplied by 3.
Okay, so I'm going to take row 3 and subtract 3 times row 2. That should work. I want you to appreciate here that using row 3 and row 1, for example, would be a bad idea. Do you see why that would be a bad idea? Because let's say I wanted to use these guys to create a 0 here. Do something like, oh, multiply this by 3 and that by 2 and then subtract them. You could create a 0 here, right? What would be the problem with that is you'd lose the 0 here. And that 0 is important. That 0 makes sure that this guy is a pivot. So once you create these zeros that you're deliberately trying to create, do not do anything to lose them. Once you have the 0, don't lose the 0, right? So using row 1 would be a bad idea. What I'd want to do is create a 0 here by using rows 2 and 3. Because then over here, nothing I do is going to affect the zeros that I already created. Right? So using row 2 and 3 should probably be where I should be focusing on. But the goal at the end of the day is to get a 0 in that position. And this operation is a type 3 operation that accomplishes that. So yeah, I'm going to take this minus 3 times that, well that's 0. This minus 3 times that, that's also 0. This minus 3 times that, that's a 1. This minus 3 times that, that's a 2. So now you see the pivots kind of are cascading off, and I have zeros all in the bottom. That's good. Now I know that my next goal is to like eliminate all these guys. Right? So that would be sort of the next plan of attack. start eliminating numbers above, let's say, eliminating non-zero numbers. Above the pivots. It's nice up here to actually start the process, start bottom up, focusing on the rightmost distance. I find that keeps things a little bit nicer for a human being to do. What does that mean? Well, this is the pivot in the bottom. Let's make sure he's comfortable first, which means I want to eliminate these two things first. Now, one way I can think about that is let's just go from the bottom rightmost. That's going to be the first guy I want to kill, right? So now I'm thinking of all the legal moves I have, what's the easiest way to kill that guy?
I don't think any move to kill someone would be legal.
In math, it's okay. So the last row is actually in a pretty decent position, so I'm not really going to even be changing that much. But now I want to do something to create a zero here. What can I do? Row 2 minus row 3 will accomplish that. So 0 minus 0, 0. 1 minus 0, 1. 1 minus 1, 0. 6 minus 2, 4. Then my next one to kill is going to be this. How can I accomplish that? Suggestions?
Row 1 minus 3 times.
Row 1 minus 3 times row 2 can accomplish that. So 1 minus 3 times 0, still a 1. 2 minus 3 times 0, still a 2. 3 minus 3 times 1, well, that's 0. 13 minus 3 times 2, 7. So now this guy is golden. He is to the right bottom most, and he's the only non-zero number in his column, so that guy is fine. This guy's also pretty fine. He's the only non-zero number in his column, and he's the pivot in his row. The problem is this guy needs some work. Yes, he's the pivot in his row, but he's not the only non-zero number in his column, which means the next goal is to kill this too.
I don't know whether or not I should.
And what move can I use to kill that too? Yeah.
Row 1 minus 2 times row 2.
Yeah. Row 1 minus 2, row 2. So that's going to be 1 minus 2 times 0. 2 minus 2 times 1. 0 minus 2 times 0. 7 minus 2 times 4. And then everyone else, I just recopied. And what's this? Just reduce our echelon form. Now, anyone who actually got through B, how many of you did it in 4 steps? So what I've noticed is sometimes when the student can get to the answer, they take an excessively long time to get through it. And I find just keeping these little cues in mind will actually get you to the answer a lot faster. Make the game focus on the pivots, right? You're always thinking of how can I establish these pivots and get them comfortable. It's usually easier from my experience to actually get the zeros below them first, then work on getting the zeros above them. But you're always focusing on the pivots and getting the zeros in the right position. every move you make should be creating a 0 at some point. And the quicker you can do this, the better. And that's kind of the focus here. So you're not just randomly moving these numbers around. I've seen students do things where they undo things that they already did and all that stuff. If you kind of focus on the pivots and creating the zeros in the places that you need them, you'll pretty much get through this problem as efficiently as humanly possible in general. Yeah.
If you get a row like where in the left 3 columns there's 3 zeros and then there's a constant on the right in that row, that can't be right? Because that's like 0x plus 0y plus 0z equals a non-zero constant. That means you made a mistake, right?
Well, we'll see. We'll do more examples. It turns out that there are 3 possible scenarios you can end up with, and that's one of them, and we deal with that separately. But yeah, so this is the actual row reduction to get into RREF, but the goal was to solve the system. Now, based on what this looks like, can you actually solve the system? Can you tell me what the solution is?
X is equal to -1, y is equal to 4, z is equal to 3.
Yeah, that's the answer. And literally, if you were to type that equation that I gave you into your TI-9 or something like that, this is actually what it would do. It would get to this, and then it would do what you just did, and it would output this on the screen, right? So your calculator isn't doing like a substitution and blah, blah, blah. No, it literally does row reduction. It plays around with numbers, because computers are great at arithmetic. It brings it to this position, and then it spits out that answer that conforms with the matrix. So you pretty much tell the calculator how to actually read the solution after it goes through all this arithmetic. And as it turns out, as we will see, hopefully today, but if not by next class for sure, there are only really 3 situations that you need to program this calculator to handle. So, yeah. And again, kind of like I showed with the second example, this is in row echelon form. In fact, we were in row echelon form since right here. You could actually stop the process here and solve the system, right? This tells you that z equals 2. You could then go and plug it in here and solve for the y. You can then plug in both the z and the y and solve for the x, right? So you could stop this, but I actually want you to get practice on actually going through these kinds of calculations. So I said, bring it all the way to reduced row echelon form. But if the point is to solve the system, row echelon form is actually good enough. It just requires a little bit of back substitution. Reduced row echelon form, you can kind of usually just read off the answer without any further calculations. So let's look at the second example, C. Okay, x minus 2y plus 2 minus x plus y minus 2z equals 3, and 2x minus y plus 2z equals 1. So usually by test day, no one has a problem actually getting from the equation to this, so I'll just plug it in. Okay, now from there, things can often fall apart very quickly. But now based on the previous tips I gave you, what would be your next, what would your next matrix look like? What would you do to the top row? Nothing. Like that's actually in a pretty good position. That's the easiest thing to do, nothing. But now you immediately want zeros below him. How do you get them?
2 row 2 minus
2 row 2 minus plus row 3. Sure. There's an easier one though.
Row 1 plus row 2.
You can add row 1 plus row 2. And I can put your suggestion at the bottom. Not because it's a worse suggestion, it's just it's a harder thing to do. I'd probably think of it second. So like 2 row 2 plus row 3. So that way you already kind of have a game plan in your head. It's easy to knock out the arithmetic once you kind of know what you're aiming for. So I know that's what I'm going to do for the second and the third rows respectively. So I just add these two. This plus that, 0. This plus that, minus 1. This plus that, 1. This plus that, 1. And that's the second row. Then I'm going to do 2 times this plus that. 2 times this plus that, 0. 2 times this plus that, 1. 2 times this plus that, minus 1. 2 times this plus that, 7. Right? So notice that this is good. I have established this pivot. There are zeros below him. That was a good first step, pretty efficient. If you take like 3 steps to get these 2 zeros, you're being inefficient. You're taking longer than you have to. You should be able to get the zeros underneath pretty quickly. One step's usually, maximum 2 steps if the numbers are particularly ugly. Yeah. So now the next goal would be to establish the pivot in the second row. So I want to pivot here. Easiest way to do that?
Switch rows 2 and 3.
You can switch rows 2 and 3. It's also pretty easy to just multiply through by -1. So let's actually do that one because the 7 is a larger number. I'd rather keep the number small. So I'm going to take row 2 and times -1. Now I know whatever I do next, I want a 0 right here. Right? That's going to be important. Without losing the 0 that I created before. What's going to give me the 0 here? Row 2 plus row 3. This plus this, 0. This plus that, 0. This plus that, 0. This plus that, 8. So your third step should look something like that. And here comes the comment that was made just before. Now here you're like, hold the phone. Now I wouldn't even continue this process because that was actually strange. Did I make a mistake? Go through and you check. The fact that you labeled each step should help you in your check. Okay, let me double check this. Okay, add these 2. Yep, I definitely did that right. 2 times this one plus that one. Yep, definitely did that right. Multiplication by -1. No way I could mess that up, but let me double check. Okay, -1 times this plus 1. Okay, okay, so that's right. Add these 2. 0, 0, 0, 8. Okay, so I didn't make a mistake. But this is strange. Why is that strange? Row 3 says, yeah?
I mean, kind of says like nothing equals 8.
It says nothing equals 8, right? It says 0x plus 0y plus 0z equals 8. In other words, it says 0 equals 8. What? WTF? 0 does not equal 8. I mean, probably not a math genius, but I know that much. This is not true. So now, what do you do when that happens? If you're sure you actually didn't make a mistake, that implies one thing: the system has no solution. Because if it did, 0 would actually equal to 8. And if 0 equals 8, I can divide both sides by 8 and get 0 equals 1. Then I can just use all these 1s to build up to any other integer, and then I'd actually get that 0 is equal to every other number. Then we won't have a number system, because the only number in existence would be 0. And then this whole math thing is all a sham. Life doesn't have any meaning, and then it's really bad from there on. So, yeah, we can't have the 0 equals 8. So we say the system has no solution. Right? And now you might be wondering, well, how would I know, besides this, that the system has no solution? Well, that's the good thing about this method. That is the only way that there's going to be no solution. So let me actually just state that. this represents Now that's an important comment. I've had students in the past where they're trying to get something to go into reduced or echelon form, and 10 steps later they can't get it done, so they tell themselves, well, if I couldn't figure it out, it probably has no answer. And so they write no solution at the end, but when it really does have an answer, they were just being inefficient. And I'm like, you can't make that conclusion unless you're in this specific scenario. If you have numbers all over the place that are 0, don't just assume there's no answer because you can't figure it out. You are doing something inefficient. So this is the situation. If you have 0, 0, dot, 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 a bunch of zeros, the bar, and then a number over here where a is not 0, means no solution. And it's the only situation you have to worry about. It is the only way you can make that conclusion. Every other scenario will mean that there's some sort of solution. And we give the system a name based on this kind of thing. We call a system that has no solution inconsistent. Probably because it's inconsistent with the rules of arithmetic. 0 does not equal 8 or something that's not 0. Systems with some kind of solution. And you might be wondering, what do you mean some kind? How many kinds of solutions are there? I'm going to show you. Are called consistent. So what you can say is the system that I wrote down for part C is an inconsistent system. It's a system without solutions. To try to find variables that will work in this system, you'd have to have 0 equals 8, which we know is not true. Since 0 can equal 8, there's no way for me to actually find the variables. And the row reduction screams that at you by showing you a row like this. You have a bunch of zeros, ending with something not 0 means no solution. And that's the only way to determine no solution, so don't worry about any other ways out there. So if you get something like this, and you're sure you didn't make a mistake, it means there's no solution, and you should just write that no solution. Just stop. Stop doing whatever. Let's look at D. Maybe I'll just write down the matrix since you already have the expressions written down. Okay, so it should be a 1, minus 2, 3, minus 2. Should be a minus 1, 1, minus 2, 3. Should be a 2, minus 1, 3, minus 7. Let's do this one. So you might notice that the coefficient matrix looks pretty much the same as the last one. I think it's exactly the same. So let's go through the same steps. I'm going to leave row 1 alone. That already kind of has what I want. Pivot in the top leftmost position. So doing nothing was the easiest thing. I want to create zeros below it, so I know I want zeros here right away. Quickest way to get a 0 here is to just add rows 1 and row 2. This plus this plus that, this plus that, this plus that. Quickest way to get a 0 here is to say take 2 times this and add it to that. 2 times this plus that, 0. 2 times this plus that, 1. 2 times this plus that, minus 1. 2 times this plus that, minus 1. So now the next goal is to get the pivot here and eliminate the guy below him. So then I'm going to move to quickest way to get a pivot here, I'd probably swap the rows, put row 3 up here. 0, 1, minus 1, minus 1. And then to eliminate a 0 here, what can I do?
Probably do row 3.
Take row 2 plus row 3. 0 plus 0, 0. Minus 1 plus 1, 0. 1 plus minus 1, 0. 1 plus minus 1, 0. So I feel kind of weird about this, but 0 does equal 0. So I will timidly continue. Because technically nothing is wrong. So I kind of noticed that. Everybody died just now. Like, both sides died, okay? So it was a massacre. But technically, nothing is wrong that both sides died. Because ultimately, if you wrote this down as an equation, the equation is true. It's not very helpful, but it is true. 0 does equal 0. Okay. So let's continue. So as far as I can see, there are 2 pivots to this system, not 3 like in part B. So if I continue now, what's the next thing I want to do to get this to reduce the echelon form? This guy needs to die. Okay. So quickest way to get that guy to die.
Row 1 times 2.
Row 1 plus 2 row 2. Yeah, so this plus 2 times 0, die. This plus 2 times that, 0. This plus 2 times that, 1. This plus 2 times that, minus 4. And 0, 1, minus 1, minus 1, 0, 0, 0, 0. So this is in reduced row echelon form now. Any row of zeros is at the bottom. First non-zero number in any row is a 1. The ones appear to the right of the guys above them. They all have zeros below them, and they are also the only non-zero number in their column. So this is reduced row echelon form. Good job. That 0 equals 0 situation still kind of bugs me though. How do we actually deal with that situation? So here's how you actually want to think of the pivots. The pivots indicate the guys you can solve for. So for example, you'd still from the bottom row up. Now row 3, you'd realize you get 0 equals 0. There's no info here. So usually you won't even write that down. So starting from the bottom row up here means starting from row 2. Now what does row 2 tell me? Well, it tells me 1y minus 1z equals minus 1. Okay? Now what you want to think of the pivot in that row is this indicates the guy you want to solve for. Right? That's going to be the subject of the formula. Because remember, when we were in the situation where we had this guy look like the 3x3 identity, the 1 just indicated, hey, that's the variable that I can get the answer for right away. So what you're going to do is just go through the motions and solve for that variable. And that is what your y is going to do. Then you're going to keep going. So if you go to row 1, you are going to see that you have x plus z equals minus 4. Now this indicates that you want to solve for x because he's the guy that holds the pivot. Pivot, everything hinges on that guy, so you're going to continue to solve for the x. You get that? Now you might wonder, what is z equal to? Well, we don't have an equation that restricts what we can choose for z. There's no equation that deals with it. I have one that for y, I have one that tells me for x, but there's nothing for z. So what do you do with the z? Well, you do something kind of silly. Set him equal to himself. Just say, all right, z, you can do whatever you want. You're a free agent, right? So this guy here, he's called a free variable. This variable may take on any value. Okay. Now, what you want to notice here is that each value of the free variable will yield a solution. Okay. Let's actually try. Suppose I set z equals 0. What now happens to my system? What would the x be? Yeah,
-4.
-4. What would the y be? -1. And you can check for yourself in the original equation. That list of variables actually solves the equation, the system. Plug in z equals 0, x equals -4, y equals -1 into the original system, you'll get all the equations actually check out. Now here's the interesting. If I were to set z equals something else, like say 1, now the other variables are going to react to that as well. My x is going to be equal to, well, -4 minus 1, -5. And my y is going to be -4, -1 plus 1. So that's going to give me 0. And you know what? Plug those list of numbers into the system of equations, they'll also work. And you can do this for literally anything. Set z equals pi if you want. You'll get a list of numbers that will work in all three equations. And you can go home and plug in numbers to your heart's content. You'll realize that all three equations will be solved all the time by following these instructions. Set z equal to itself, compute all the other variables in terms of that guy. So, here's a question. How many solutions are there?
Infinitely many.
There's an infinite number of solutions. Infinitely many. Now it turns out that, like I said, and we'll definitely get to this, linear systems have a lot of applications in business and technology and in all sorts of stuff. And sometimes there'll be multiple ways to solve these systems. In fact, multiple is kind of an understatement. There have been an infinite number of ways. And you ever wonder why, you can have this really sophisticated machine like Google or this other big company that these guys are billionaires, they hire the best, most knowledgeable people. Why can't they fix something without breaking something else? A lot of the times what is actually happening is that there are tons of ways for them to solve a problem. They just try to pick one. Now one will give you something you want in one position but something you don't want in another position. And the thing is, no matter what they pick, you'll probably never find anything that will fit the situation perfectly. They're just going to pick the solution that, the least number of things will break this way. And so, yeah, you're going to have people complaining about those few things, but on the whole, it's more of a wholesome solution. Sometimes you won't have an answer at all, like we had in the previous situation. Sometimes you have an infinite number of answers to choose from. They're not all going to be perfect. Maybe none of them are perfect, but you try to do your best. And that's, I guess, another life lesson for math, because sometimes you just got to do your best, Just like your life is never going to be perfect. Just try to get as many of the variables to line up as possible and deal with it. In this situation, I want you to notice what was the indicator here. or maybe let's review. Let's talk about all of them. And I want to make some notes here. Remarks or things to notice. In B, so the first 3x3 examples I did, I want you to notice we had 3 pivots. In C, we had less than 3. We had 2 pivots, but a row like 0, 0, with something not 0, which indicates something bad. In D, we had 2 pivots, but no row like this, right? You can actually create a theory based on solely the pivots. What I want you to notice is that the number of columns in A was what? Remember, A represents the coefficient matrix for the system. AX equals B. How many columns was in A? 3. So here's the thing to take away. These 3 examples actually illustrate all possible scenarios for a linear system. So this is what we call the variety of solutions. And this is actually a theorem. 1, you can have a unique solution. In the first 3x3 system we solved, we had 1 coordinate that solved it. The x had to be particularly -1, the y had to be 4, and the z had to be 2. There were no other arrangement of numbers that will do it. 2, you can, so unique means 1. You can have an infinite number of solutions. Or 3, you can have no solution. So the first 2 cases, these are called the consistent cases. And the last case is called the inconsistent case. And it turns out you can describe them by the pivots. Whenever the number of pivots equals the number of columns in your coefficient matrix, you will have 1 solution. The moment you have less pivots than is in the column of your thing, you will either have an infinite number or no solution at all. How can you tell the difference between the 2? The one with no solution will give you a row like this. The one with infinite solutions will not. The one with infinite solutions might give you a row of entire zeros, or it might not even give you a row at all, but you would have less pivots than there are columns in your coefficient matrix. There is no other possibility. So if you answer a linear system and you tell me, oh, these 2 coordinates work, but no other ones, you have no idea what you're talking about. That is an impossible situation. You would have 0, 1, or infinitely many. There is no in between, there's no other situation. Maybe next time I'll talk a little bit more about that, but we'll do that. I will give you some homework that helps you practice the row reduction, because you need to be quick and efficient on that for the future stuff. And I will see you guys on Monday.
Oh, okay.